Hello all, Ralph Bean here, reporting for the Modularity Working Group Sprint demo. The stuff that I've been working on is almost entirely captured in this wiki page that you can see here at the top in my browser, the modularization slash infra. And so what I'm trying to do is figure out what we need to do in the infrastructure, in Fedora infrastructure and all of our services to accommodate modularity, and then at the same time figure out if the opportunity that presents us with modularity is going to give us any chances to make other general improvements to the build pipeline and to all the services that we run. So as part of the process of going through this, one of the first things we did was come up with a diagram that we brainstormed about what it takes for a package update currently to make its way through our infrastructure. So we devised this diagram that talks about what a packager does and how they submit it to our systems and what systems it kind of has to go through. There's a rawhide build in here. You can look at this diagram in more detail, but just kind of to rush through it and show that there's different streams for rawhide, and then for released updates, and things kick off into Taskatron, other things check and gate on that. So a lot of that is captured here. It certainly doesn't capture everything that happens because we couldn't just possibly fit it all in a diagram, but we tried to find the parts that we thought were important to think about when we wanted to think about modularity too. So further down the page, we then hypothesized what a workflow would look like for a module update if we had the kind of elementary infrastructure to even support building and shipping those at all. The kind of key omission from this diagram is that there's no automation whatsoever, and that was intentional. We wanted to see what kinds of impacts modularity would have on packager workflows if we didn't provide any automation, so then we could identify what exactly the pieces are that we did want to automate in a subsequent diagram. So again, check out the wiki page and look through this and see if it meshes or if you have any questions. There's kind of 4 main columns coming in from the top that describe different flows that a packager might interact with modules along. And there's descriptions of them in more detail down here. The 4th one is the most interesting and probably the most controversial, and then it opens up a question about how we pin versions inside modules and what impact that would have on backporting security patches and things like that. Things that we're going to have to be able to do if once we get along, I'll say. So then the last and kind of major part of this page is this proposal, the beginnings of a proposal for a variety of changes to the infrastructure. Everything here in a yellow box, everything here in a white box is a system that exists and that we don't think needs to really be modified at all. Everything in yellow is a system that does exist but needs to be modified in some way for modularity. And everything in green is a system that doesn't exist at all and that we think needs to be written to accommodate this new kind of content flowing through our pipes. And so let's see if I click on this. Is this going to work? Good. It was scrolling. So you see up here on the left, we have like a module developer and a component developer, what a packager is today, both interacting with dist-git in the same way they did before by using tools like fedpackage and git to make changes to spec files down here and up here to these module metadata YAML files, both going into dist-git. Still producing message bus messages like they do now, which we'll use to trigger further automation here. 2 of the things that we'll do right off the bat when module metadata changes is that message will be picked up by PDC Updater, a service that we already run and use, but which will be modified to understand this module metadata, which will then in turn post a representation of those dependencies to PDC, the Product Definition Center. And we're going to use that to model the dependency graph of all the modules, what they depend on, as well down to the component level, to have something queryable to then use in further automation down the road. We think also, and this depends on that debate about how we pin versions, we think we may also need to have a system here that simply just models and remembers the branch history in dist-git just for modules, and there's some discussion of that in the wiki page. I'll skip it here. Let's see, I'm going to zoom out a little bit and scroll over. There we go. The kind of meat of this diagram is this interaction here right in the middle, which is, you can see Koji over here, the Koji that we know and love. We're going to build modules in Koji, and we're working on the details for that. It may involve a content generator, or it may involve some native Koji tasks that we introduce that set up build routes for each module and rebuild the components from source for that module there. But the interaction here is what's of interest for this diagram, in that when you update a module or a component that a module depends on, depending on the circumstances, we may need to rebuild a large chain of things, a large chain of dependencies. So rather than baking a workflow engine into Koji itself, we're going to create a service, a standalone service for it, which for now is just called the orchestrator, which will simply schedule builds in Koji of what it thinks, my phone, excuse me, what it thinks needs to be built, which will then be built in Koji, be passed through Taskadron for validation, which then comes back to the orchestrator, at which point it can query that dependency graph to figure out what other things depend on that module that just changed, what subsequent tiers of modules depend on it, and then it can trigger another round of rebuilds. And so this kind of cycle between these three systems, we intend for it to come to a completion where the whole tree then arrives at a fully rebuilt state. Zooming out a little bit. So that's the packager process up here. Here's this automatic rebuild interaction in the center. Down here at the bottom of the diagram is captured some of the compose and release engineering tasks. Punji we want to still use as the thing that currently pulls together all the RPMs that we've built and produces the different variants and all the artifacts associated with those variants. We want to do that as well. You can think of the orchestrator in some ways as a kind of ad hoc Punji task, where Punji, currently the way it's written, schedules a number of tasks in Koji to assemble all these artifacts, and then it collects them and prepares them to be rsync to the mirrors. The orchestrator you can think of as kind of building those things before they're even asked for. So Punji's role will kind of change. We'd like to move more things to the orchestrator, so compose constituents, compose parts are ready, and then in the best case scenario, Punji just harvests all of those whenever we ask for a compose. In the worst case, say none of them are pre-built and not ready, so Punji will act just like it does now and schedule all of those builds, harvest those artifacts, and then do the kind of thing we do now, rsync them out to the master mirror, those go to the other mirrors, and I'll move my little photo here. Down here, client tooling, right, is pulling module metadata and module content from the mirrors, just like we do now with Yum repo metadata and with Yum and with RPM content. Interesting things here. You can read more about it on the wiki page, but we want to build a comps We want to build a comps as a service to modernize the way we currently handle comps.xml. I mean, the way Punji puts together the composes by looking at a bunch of comps groups, and we want to put together composes instead in terms of modules and say, Fedora server is composed of these modules, so therefore comps needs to be able to define things in terms of modules. If we're going to be changing comps, it would be cool to also make it a service, so we can, instead of having to schlep around this XML file in our infrastructure, we can have something to query and manage and have history of. We have the history now in Git, I know, but comps is getting a little old. People have been concerned we can get rid of comps, we won't be able to have Yum groups anymore. For sure, we will still synthesize a real comps.xml kind of at the end of Punji, which we can ship out to the mirrors for client tooling, old client tooling that still depends on comps.xml, so don't worry about that. Over here, some other kind of tertiary things. These are two optional services, is the way I'm characterizing them, that could be nice. People have asked for a service that allows for pre-computing dependency resolutions for clients so they can do really fast queries. We can already do dependency resolution pretty fast now, and pre-computing could be cool. We might be in a more sluggish situation once we have modules, but the FM metadata service here could pre-compute those and serve them. We would need to update the metadata there from Punji via the message bus, right, once a compose is done. And then lastly over here is a really interesting service that's really orthogonal to all the modularity work. Consider it optional for the priorities of the working group, I think, but having a kind of build pipeline overview service would be interesting, so that with all this automation in the middle, it would be nice for developers, particularly distro developers, to be able to ask, hey, I've got this module X, I have this version installed, is another build in flight in the build system? And so maybe it's not on the mirrors yet, maybe it's already built, but it's not distributed yet, or maybe it's part of a chain rebuild that hasn't even completed, hasn't even got to that module yet. So it would be nice to have a homogeneous interface where you could ask about all kinds of different kind of artifacts in the build system and where they are at in the state of this whole process of automation. Otherwise, it'll be kind of confusing and opaque, right? Like, is the build system done? I don't know. What's it doing? It's all magic now. How does it work? So this is kind of a window for developers on the whole thing to figure out what is going on. So that's all I have. Thank you very much.